Hello, welcome to this video and previous tutorial. In this video, look at chemistry revision. The question says the diagram below shows 4 different methods of separation. We have A, B, C, and D. A says using the letters A, B, C, and D, identify the method used to separate insoluble particles from water. Now, before we go anywhere, we need to understand what an insoluble thing is. Anything which is insoluble, it means it cannot dissolve. Alright? Cannot dissolve in a liquid. Now, something that cannot dissolve in a liquid, let's for example, say sand or stones. These are stones. Then these stones are in water. So this is a beaker. These stones are in water. How can I separate stone from water? I'm going to use filtration. C. So the answer there is C. Separate a mixture of different dyes. Now, different dyes can only be separated by chromatography. That's B. And 3. Make crystals of copper 2 sulfate from copper 2 sulfate solution. How can you? They're saying you have a solution of copper 2 sulfate here. Now they want you to make crystals of copper 2 sulfate from here. So you heat the solution so that it can crystallize and form what? Crystals. So you use crystallization, which is here at D. So I hope my explanations are clear and direct to the point. Then we have 4, let's say, separate water and cooking oil. Now remember that water and cooking oil cannot mix. Water plus cooking oil, this cannot mix. All right, cannot mix. Hence we call them immiscible liquids. Immiscible liquids, they cannot mix. Let me just give an example. What's going to happen that since water, something which is denser than the other will be down. Right, so let me just give you an example. Right, I'm talking about, let's say, which one will be up? Let's say this is cooking oil. It's up. Then we have water. All right, we have water now. So this is cooking oil. Then we have H2O here. So what's going to happen is that this cannot mix. Why? Because they've got different densities. This one has got a density, and this one has got a density, but different from this one, also different from this one. So what's going to happen is these can't mix due to differences in density. So we use what we call a separating formula, which is A here. A. Hope that's clear. State 1, industrial application of chromatography. How can you use chromatography at industrial level? How can you apply it? 1, chromatography is used. Chromatography is used in what? In determining purity of substances. Substances in what? In laboratories. It's also used to see drug abuse in sports. It has got a lot of applications actually. Okay, let's go to this question. It says 2 elements A and D are represented by the notation shown below. A, B there, D there, sorry. Draw electronic shell diagrams to show the arrangement of electrons in the atoms of A and D. So, how can you show the atomic arrangement of atoms? But when you look at A here has 23 and here has 11. Now, which number we're going to use? We're going to use the number which is the atomic number. So, the electronic configuration of atom A, it's 2, 8, 1, because there are 11 there. So we'll say that, so this is A, that, then you end with 1. You're done. Then for B is 8. So the first shell, let me say this, the first shell has 2, second shell has 6. So I'm using dotted here so that I differentiate it from A. And then like that. Then B1 says what? B1 says when atoms of A and atoms of D react together, what type of bonding occurs? Now, you need to know, is this a metal or a non-metal? Now, when look at here, we had 2,8, 1. Here we had 2,6. The last number of electrons in the last shell, they show the group. So this is that means element A is found in group 1, and group 1 elements, they are metals. So we know that A is a metal, and D is found in group 6. Group 6, they are non-metals. So it's a reaction between a metal and a non-metal. So this is what we call ionic bonding, or if you can call it electrovalent bonding. All right, no problem. Then 2 says, using the dot and cross diagram, show the structure of the compound formed between A and D, showing all the electrons. Now, you need to know that this is A, this is D. So, to form a compound, this means since A is a metal, it has to lose an electron. But D needs how many electrons for it to have 8 electrons in the last shell? It needs how many? Oh, sorry, I made a mistake here. Pardon me. It's supposed to be like this. It's supposed to be 6. So for this one to have 6 electrons, sorry, 8 electrons, it needs how many? It needs 2 electrons. Now, for the, remember, we only have one atom of A. So therefore, this one needs to gain 2 electrons. This one is losing 1 electron. When you cross multiply, we are forming A to D. Now, since we are forming A to D, that means we need 2 atoms of A and 1 atom of D. So it's for sure we know that we need 2 atoms of A. So I'll do this. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. I won't show the last shell because it has already lost an electron. I'll just show this. So I'll show something by that. This is a symbol that it has lost an electron. It has lost an electron. That's why it's no longer having a 3, it's only having 2. So this is A, this is also A. Remember the formula is we need 2 atoms of A. And now this is forming D with this. So now remember that D is gaining those 2 electrons from here and from here. So it's going to be like this. I'll differentiate them, this and a negative 2. You show the gain of electron, I'll also show the gain of electron, saying there's a loss of what electron? 2D. So D is a non-metal, it's gaining electrons. Okay, I hope that's clear. State 2 physical properties of the compound between A and B. Now we know that the compound between A and B, it's an ionic compound, right? It's an ionic compound. And what are the properties of ionic compound? 1, they are solids at RTP. Second, they have high melting points. Third, they have high boiling point. Third is that they conduct electricity only in molten state. Right, so thank you so much for watching, for joining me in this video on previous editor. Please don't forget to subscribe to my YouTube channel, share my videos. My students, please study hard chemistry, understand the language of chemistry and what you are being asked. Thank you.